talk about indirect measurement and the proportional area theorem. So those are two things we got to get down today. And hopefully have time for an activity, although third period we ended up not having time, but we'll try to squeeze it in. All right, so okay. First of all, joke. Get us all started. How many seconds are there in a year? Okay, I know I'm not that funny, but it's a joke, not a math problem. So anybody have a guess? 12. January 2nd, February 2nd, March 2nd. Get it? Do I get it? Like the 2nd of January, not. Hilarious, right? Chris said it's so funny. He's pounding the desk. It's so funny. All right. That had yeah. All right. All right. So so indirect measurement means finding the height or the length of something without actually measuring it with a yardstick or a ruler, okay? So finding the length through an indirect method, right? Direct means just walking from here to there. Indirect would mean like walking around and getting back there. Okay, so if I wanted to find the height of this call box, this police box, and it's too tall for me to climb up and measure with a yardstick or tape measure, what I would do is I would set it proportional to something that I already know. And the nice thing about the sun is it always provides that similar relationship. Because if the sun's shining way up here, it's hitting this call box at the same angle as it's hitting this guy. So it's casting it. So the angle from the call box to the ground and the angle from the guy to the ground is the same. So if this is the right angle and this is the right angle and those angles are the same, are they similar figures? Yeah, why? Right, right. Angle, angle. Similarity. Not just angle, angle, but angle, similarity. Okay, so I can set up a proportion and solve for the missing side. So what does this side go with? 7 feet, 8 inches. So 15.5 feet goes to 7 feet, 9 inches. Okay, and then what? What's on the other proportion or other ratio? X, because we don't know the side. Right, over 5 feet, 2 inches. Right? Okay, now, can I get on my soapbox for just a second? When you guys are congressmen or senators or the president, that'd be the most awesome, so work on that. Will you please, as soon as you take office, get rid of the standard measurement system and adopt the metric system? Standard measure is so annoying, and it's really only us and this little island in the Pacific. It's the only people left that use standard measure. And it's so hard, and it's so annoying. And like we can't even do math with this. You can't calculate like this. You have to turn everything into inches first and then turn it back. It's hard. So as soon as, like, make your first State of the Union address be, we need to adopt metric system, because the standard system is just annoying and hard. So will you promise me to do that? Yeah, I don't know. When I was in school, like when I was in high school in the 70s, we all learned the metric system. It was the net, we were all switching over. It was done. And then nothing ever happened. Like, I don't know. So that's why when you become president or congressman or senator, you need to change it. Okay? Promise? Promise? Thank you. Thank you. Okay. So we cannot, like I said, you cannot calculate like this. You can't, and is 7 feet 9 inches 7.9? No, because it's not base 10, it's base 12. So we got to change everything into inches. This one is a decimal, so really this is 15.6 inches, but we can just multiply this by 12 to get the total number of inches, right? So what is 15.5 times 12? 186. Okay, and then 7 feet 9 inches, I have to take the 7 and multiply by 12 because that's feet, and that's what, 84 plus, and then the inches was already inches, so I multiply this by 12 and then I just add this. So 84 plus 9 is 93, right? Thank you. Okay, and then x, and 5 feet 2 inches, 5 times 12 is 60 plus 2, 62. So now I can solve it after I get it all rearranged. 186 times 62 and 93 times x. What is 186 times 62? 532. To divide by 93, and I get x is equal to 124. But I'm not done because we're still using standard system. So I have to change this into feet and inches again. So to turn this into feet, I would divide by 12, which gives me what, 10.3333, right? Which 0.333 is 1/3. What's a third of a foot? If 4 inches, right? Because there's 3 sets of 4. So it's 10 feet 4 inches. Okay? Now, really quickly, let me just, if this had been not something easy like a third, if this had been like 10.8792, something like that, okay? To turn that into feet and inches, I would, so first you take away the feet, so subtract out, if that's in your calculator, subtract out the 10, so that all you have left is a decimal. And then you're just trying to figure out how many inches that is, so you just multiply by 12, and I think that gives you like 10.5 or 10.6, something like that. So that would be 10 feet and almost 11 inches. Does that make sense? So that's how you would, if it doesn't come out to be something easy and neat, that's how you would turn it into feet and inches. Okay? No? Okay. So the first thing you do is need to get rid of the feet because you've done that already. You've covered that. So all you want left is the decimal that represents how many inches. Okay? So you're trying to find you have basically 8.792 part of a foot, of a single foot. So you're just trying to find out how many inches that represents. So you multiply that decimal by 12 because that'll tell you. So you're basically saying what is 0.8792 of 12. Right. So yeah, so you still have a decimal, but it's like almost 11 inches. Yeah. I mean, at that point, it's such a small thing that usually, unless you're NASA, you know. I mean, well, that's for another day. Remind me to tell you my NASA story about metric and standard, because a day when we have more time, because it cost the United States millions of dollars when I was working for NASA, and it's all because we can't seem to get our minds around the metric system. All right, so does that make sense to everybody? Yeah? Okay. Then take a second and find the height of that pineapple, of the giant pineapple. We got Myrna here, who is how tall? 5'4". All right, so see if you can find the height of that pineapple. So, rewind. So the proportional perimeter and area theorem compares two similar figures, and you can calculate the perimeter and the area based on the similarity ratio. And what's a similarity ratio again? What's a similarity ratio? What is it? What's the similarity ratio of these two figures? Yeah, 9.1/13. It's a ratio of the lengths of the sides. That's a similarity ratio. Remember, we've been calculating it for 3 or 4 days. Okay, it's a ratio of the sides of two similar figures. And see, they told us that these two figures are similar. All right, so I set up my proportion, or my ratio, which is 9.1 to 13, or you could do 13 to 9.1, that's fine. But this is a similarity ratio, right? So if I wrote ratio on your Quizlet yesterday, this is the part you were missing. It's that ratio of the sides. Okay? Now, how do you get perimeter? Yeah, you just add up the sides. Okay? So if I want to find the ratio, or if I want to find the perimeter over here, I can use, according to this theorem, I can use a proportion. Okay? Remember, in a proportion, you have one side you have to know, and the other side you can solve for x, right? As long as you know both of one side. So I'm going to use this ratio to be my left-hand side, and it's going to be equal to the ratio of the perimeters, because basically I'm just adding the sides up. So shouldn't the ratio of each individual side be the same as the ratio of all the sides added together? Does that make sense? So all these sides added together is 36. Oh, yeah, it should. Thank you. Yeah, that's the most common mistake that I just made, is you make sure that since the perimeter goes with the 13, it has to be across from the 13. All right, and then the perimeter of this shape is what we're looking for. So I cross, multiply, and solve. So I get 13x equals, I don't know, what is 9.1 times 36? 327.6. Divide by 13, and I get x is okay. So could I have found the perimeter any other way on this figure? No, because I don't have enough information, right? But this gives me another tool in my tool belt. So if I need to find the perimeter and I'm not given enough information, I can look and see, hey, is there anything it's similar to that I do know the perimeter of? Because I can set up this proportion and figure out what the perimeter over here is. Does that make sense to everyone? Yes? No? Yes? You okay? Yeah? Okay. All right. Now, think about, let's take the simplest figure, a square. Okay, now I'm not talking perimeter anymore, I'm talking area. How do I find the area of a square? Right, and in a square, instead of base times height, don't we just take one of the sides and square it? Right? So, and the result is going to be like square centimeters or square inches or square some unit. Okay? So, area is no longer just comparing centimeters to centimeters. We're comparing square units. So, to find the area, I'm going to do the same thing I did before. I'm going to have the side I know and the side I'm trying to find out. Only what I'm going to do is take the similarity ratio and square it. Because now I'm talking about square units. Okay? And so I square the similarity ratio, and that's going to be equal to my area of this figure and then the area of the other figure. Okay? You'll notice, did I square the area? No, because it's already in square units, so I didn't have to. So I took the similarity ratio and squared it, and that relationship is going to be the same. That ratio is going to be the same as the ratio of the areas of the figures. Okay? I know this is, like I said, this is kind of the harder of the two things we had to learn today. All right? So 9.1 squared is 82 point something, 881. And 13 squared is 169. Because remember, when you square something, it just means multiply it by itself. So 9.1 times 9.1, 13 times 13. And that is equal to the ratio of the areas of the two figures. Okay? Then I just cross multiply and solve. And I get, Anderson, plug that in, quick, quick, quick. Okay. That's all right. Good. So the area is 29.4. Did we have enough to do 1/2 base times height on this figure? No, we didn't have enough, but since I knew it was similar to this figure, I could figure out the area by setting up that proportion. Does that make sense? All right, if it does, you try this one. I need the perimeter and the area of this bigger rectangle.